Today I'm presenting kind of very recent work about testing RAG or RAG systems, because I think this RAG or RAG system is kind of new kind of standard of the large language model applications. So I'm going to introduce two different kind of testing methodology for this specific system. Okay, yeah. So because I think nowadays everybody's using LLMs or AI coding agent for programming, and I heard that quite many programmers or developers are worried about losing their job because AI agent is just so good, and I think it is. And one thing I noticed that LLMs is exceptionally good at coding. Compared to other good skills it has. But the thing is, here I brought one quite recent article, the titled Extracting Books from Production Large Language Model. So what it does is to try to use like ChatGPT or Claude Code, the commercial language model, and try to exact book content, but the commercial books like Harry Potter, and they succeeded actually. I think it is kind of illegal because they should not be trained on such things, but they somehow succeeded. So what I want to say here is that LLM is also very good at memorizing something because yeah. But the thing is, I think LLM will not know about me. Well, it knows about me like my public profile, but it will not know about my, for example, medical history, hopefully, because I did not give any information, and usually those kind of information is confidential and hidden. But sometimes I want to get some consultation or advice from large language model about my health status. Then I need to give some information to large language model or some medical history document to language model. So to kind of handle this kind of situation, quite many LLM systems or LLM applications are adopting a system called Retrieval-Augmented Generation, RAG system. So let me briefly introduce how it is doing. So here we have a document corpus, meaning that a set of documents like my medical history document. And then given this kind of document set, it first tries to parse and chunk into the very smaller chunks so that it can handle those kind of smaller chunks effectively. And then using some text embedding models, it embed such smaller text chunk into some embedded vector and save it to the vector database. So this this specific process can be done offline because there's no kind of online thing here. And then because this is still a LLM system, there should be a user query, like a query or a question like, please look at my medical history and please answer this kind of question. And there will be a user query, and then we are going to embed, in the same way we embed the document corpus and the chunks, we embed this user query, and then compare the similarity between this embedded user query to the embedded vectors in the database, so that we can fetch or we can retrieve the relevant top K chunks from the database. And then this retrieved top K chunks combined with this original user query will be fed into the large language model so that we can enrich the context of the prompt so that we hope that LLM can answer correctly or effectively based on this top K chunk retrieved. So this is kind of very brief introduction of how RAG system works. Well, I think in many industry cases, the system is much more complex, but I think they follow the same kind of pipeline. So, but the thing is that now we have this kind of system along with large language model. But how have they been tested so far? But my answer to this question is that they have been mostly evaluated, not tested. For example, there is a very famous metric that evaluates this RAG-based LLM system. called RAGAS, and it just scores the query. For example, there is one famous metric called context precision, which is about checking whether our retrieved chunks, for example, if the top K is the top 4, then we have these 4 different chunks retrieved, and then check whether which chunk was really relevant to the final answer. So yeah, that's how context precision is computed. And the another example metric in Lagos is faithfulness. So it is more about the generated answer, meaning that given our answer, because we just produced an answer from this large language model, and then we decompose this answer into several claims, also using another large language model, and we check that which claims in the answer actually is supported by the retrieved chunks, meaning that if it is not, some claims are not supported by these retrieved chunks, meaning that LLM is just hallucinated or just ignored the information we provided. So this is how the previous literature kind of tested or evaluated the RAG-based LLM system. But here comes my 2 important questions. The first one is, if there is a test that we evaluate the RAG-based LLM system, is our test suite actually exercising the retriever? So with this question, I introduced a new coverage metric called chunk coverage. And my second question is that if there is a changes in the document, like document has been updated or just evolved, then does our RAG system stay consistent when there is such as changes in the document? So with this second question, I propose a new Metamorphic testing framework that can test or evaluate this RAG system consistency. Yeah, by the way, the first one, the first paper regarding the question number 1 is will be presented in ISTA this year, and the second one is now under review. So the first part is about chunk coverage. So it is very straightforward and simple idea. For example, you can see the small boxes here, and you can see that the black boxes, meaning that they have been retrieved so far using our test set. But you can see that the gray boxes mean that they have never been retrieved, meaning that even if there are many chunks or many documents in our corpus, but our test set actually do not care about those kind of not retrieved chunks in the data. Well, there can be a kind of stale or obsolete chunks or documents that are really not important. So maybe we can just ignore such things, but still, as a coverage metric, those never retrieved chunks would be quite important to look at, because we want to cover more chunks or document in our entire corpus. So the chunk coverage is just a ratio of this number of retrieved chunks out of the entire number of chunks. And it is quite similar to just code coverage in the software testing, because it is structural and it is Oracle independent, and it is also computed on a test suite level. So this is just to show some comparison to RAGAS metrics, because RAGAS metrics doesn't care about this distribution of the retrieved chunks. So even if there is a very popular chunks with a very high hit like this, maybe RAGAS can evaluate such chunks, but it doesn't care about the chunks that has not been actually retrieved. So we want to target such gap by proposing this new coverage metric. And what we can do simply with this chunk coverage is that we can guide test generation by targeting such uncovered chunks. So you can see here is that after calculating the chunk coverage, we will know that which chunks are not uncovered. And then based on this uncovered chunk, we can guide additional test generation. So here's a very simple experiment and result. I used the 2 different domains, the clinical domain and financial domain, because as I mentioned, these documents, I assume that sometimes hidden or very confidential. So I use these two different data set and benchmarks. And this is our two main research questions. The first one is, does our chunk coverage guided selection reach the coverage faster? And the second one is about how fast it is to find the FERT compared to random search. Because I wanted to use more prominent or better baseline, but this is the first work, so we just use the random baseline. And this is the result. We have 5 different benchmarks. And you can see the coverage guided with our chunk coverage can reach the desirable coverage very fast compared to other. Well, I'm not going to introduce this overlap bias, but compared to random, which is red in the line. And then the second result is about how fast we can find the FERT. So the definition of the FERT is that it is actually based on the RAGAS metric. So if the you can see, for example, here in this column, you can see 6 different RAGAS metric, including the faithfulness and the context precision that which I also already introduced. When their value becomes 0 to some specific test, we say, okay, this one is FERT. So I just checked whether, how fast our coverage guided metric can find those kind of FERTs by introducing new test or by selecting existing test, which is going to be a simulation. But you can see the values here are representing the average percentage of FERT detected. The higher is better, and usually the CC guided one, chunk coverage guided one is achieving higher APFD. So there was the first part of the presentation about chunk coverage, and let's move on to the part 2, which is about metamorphic testing. Because as I briefly mentioned, that sometimes the knowledge changes or document changes or evolve. For example, last night there was a UEFA Champions League match between Arsenal and Atletico Madrid. And this document should be updated based on this result. But I think LLM will not know about this unless we provide a new document, right? And also, even in this very famous Wikipedia pages have every day updated. And we want that our RAG-based LLM system stay consistent with the changes of the document. So by consistent, I mean that if there is a factual changes in the document related to the specific query, the answer to that query should change. Or if the changes does not related to the specific query, or the changes is just the syntactic changes, then the answer should remain the same. So with these two ideas, I propose 2 different metamorphic relationship. The first one is with this red line, meaning that if the context or some factual things changes, we expect that LLM answer to that specific query should change. Otherwise, answer should remain the same. So this is very simple kind of metamorphic relationship I propose. So the good thing of this metamorphic testing is that we don't need any oracle. This just the relationship itself becomes oracle. So that's a good thing. Yeah. And let me briefly introduce how this framework works. So you can see the title is the original execution, meaning that we don't care about the document changes here. So we have source original document, and there is a user query, and here is a retriever, which do the indexing and also comparison between these embedded vectors. And then we just get the retrieved context, and then using the large language model combined with this retrieved context and the user query, we just get the final output Y there. But in our kind of mutation-based metamorphic testing, what I'm going to do is to make some changes on the source document. or either I also change the some sort of hyperparameters of the retriever itself. So it means that I kind of simulate the changes or evolution of the document. So after applying these mutations to the document, I also go through the same procedure as before. So there will be in the retriever indexing and search and comparison of the similarity, and we will get the retrieved context. Well, it can change, or sometimes it is not changed, but yeah, we don't care. But we say that this is kind of mutated context. And then we put them into the same generator, like same large language model, and we will get the final output, which is y prime. So with these two different execution, which is original execution and mutated execution, what we're going to do is just compare the two different output, y and y prime. So by comparing these two output, LLM outputs, we can, and with these two different metamorphic relationship, we can decide whether LLM is consistent with these changes or not. So if it is not consistent, we say that there is a fault in the RAG-based LLM system. If it is consistent, then we say that the system is robust. So yeah, this is very simple over metamorphic testing framework pipeline. And I'm just going to briefly introduce how this mutation is done in our framework. So well, we have in total 12 mutation operator. I brought 3 mutation operator. The first one is it is called counterfactual noise, meaning that we deliberately inject the counterfactual things into the document so that we hope that LLM just mispredict the output. And the second one is called chunk merge and split, means that I mutate the retriever itself by changing the hyperparameter of the mutator, because there is some parameter that how to merge the chunk, how to split the chunk, and I just adjust the value a little bit, and I expect that usually LLM should be consistent with such small adjustment of the hyperparameters. And the last one is also about changing the hyperparameters, but I adjust this top k value, meaning that originally is top k is top 3, meaning that I retrieve top 3 chunks. But let's say I now retrieve top 1 chunk, meaning that there will be only smaller amount of the information to the large language model. So in that case, I can also hope that LLM will mispredict something, or I can say that LLM also should produce the same output. So it is really dependent on what kind of chunk we have at the time. So actually, this is not a kind of determinant thing. So every time we generate new kind of mutants using this mutation operator, we need to decide, we need another kind of judge that evaluates whether this changes to the document or changes to the hyperparameter make LLM stays the same or make LLM should change. So here is a very brief result about the experiments. Actually, I used the same same benchmark with the chunk coverage paper. And our metamorphic testing framework showed that usually, I don't remember the exact number, but there are, using the original test sets, there are 10% of the 10% of the system faults, meaning that if I generate mutants on this benchmark and large language model with this RAG system, 10% of the mutants were kind of generating the real fault, meaning that LLM was not behaving as intended. So this is just a comparison to the RAGAS metrics, and meaning that RAGAS metric cannot capture such document changes or evolution. But you see that in the last row, which is our metamorphic relationship, is usually achieving very high precision and recall, and it can also detect. For example, in this Venn diagram in the purple circle, you can see that usually our metamorphic relationship framework can detect some exclusive words as well. And actually, yeah, that is it. And just I want to say that because this ROC system is really a part of this LLM systems, I think this kind of corpus is kind of part of the, I mean, is now a kind of component of system under test. So maybe we should consider this corpus as a kind of testing goal as well, because I think there are not many papers targeting this kind of ROC system. So I think it is quite important to note that, yeah, it is important to say that this is testing target as well. And that's it. And thanks for your attention.